Question number 35 is again an open response that has 4 parts. At the beginning of the year, Samantha deposits $1,000 into a savings account that pays 2.5% interest. She does not deposit into or withdraw money from the account for 1 year. Okay, so we're going to see that all three pieces of information are important to solve each part. Now, part A says, what is the interest rate expressed as a decimal? Okay, so here we need to review how we convert percentages to decimals. Okay, now any percent, let me back up. To turn any decimal into a percent, we multiply by 100, because 100% is the maximum amount we could possibly have. So, and when we're talking about decimal places, the first place is called the tens, and the second place is called the hundredths. Okay, so when we are multiplying by 100, we move the decimal place to the right 2 places, because this is the tenths, this is the hundredths. So 100 is represented by 2 decimal places. So to convert the percentage to a decimal, we're actually going to divide by 100. And to do that, instead of moving the decimal point 2 places to the right, we are going to move it 2 places to the left. And because there is no number there, we need to put a 0 in as a placeholder. So 2.5% is the equivalent of 0.025 as a decimal. Part B gives us a formula. It says this formula can be used to calculate the total amount of money, including interest, in an account over time for a deposit of $1,000. And then it gives us an explanation of what each variable represents. So A is equal to the amount of money in the savings account after T years. So essentially A is what we're solving for. We're going to find out with accrued interest how much money is in the bank account. The thousand obviously represents the initial deposit of how much money is in the account. R represents the rate, the interest rate as a decimal. And of course, we calculated that in part A to be 0.025. T is the amount of time in years the money is invested. And in part A, it told us that there was only one investment of $1,000 and no other investments were made in that time frame. And N represents the number of times the interest is compounded in 1 year. Now, it's not necessary for you to understand what compounded interest is, but essentially what that means is each different banking accounts have different rules and regulations. So some accounts will calculate interest once a year, twice a year, or quarterly, which is 4 times a year. And all that determines is that how often they calculate how much additional money you've earned each by the specified time frame. In this particular case, we are told that the interest is compounded annually or just once a year. So that means N will equal 1. Okay, so let me rephrase that again. So N represents the number of times the interest is compounded in 1 year. And it tells us for this particular situation that Samantha's savings account at the end of 1 year is compounded annually. So it means it only happens once. So that means n is equal to 1. And the time frame, actually, oh yes. So what is the amount of money at the end of 1 year? Okay, so if you notice, T is the amount of time in years that the money's invested. So they want us to determine how much money there is after 1 year. So T will also equal 1, because that represents 1 year as well. R is our 0.025, which came from part A. And of course, A is just what we get when we calculate everything in. Okay, so what we need to do is substitute these values into this formula. So we have A is equal to 1,000 times 1 plus R over N times NT. Okay, so I have 1,000 times 1 plus, now R is 0.025, N is 1, and then we have N to be 1, and T is 1. Okay, so this is multiplication here. All right, so thankfully this simplifies quite nicely. So we have 1,000 times 1 plus, now anything divided by 1 is itself, so I'm going to have 1 plus 0.025, and 1 times 1 is 1. Okay, now we're going to remember we're following order of operations. Okay, so we have to do parentheses first. So I have 1,000 times 1 plus 0.025 is going to give me 1.025. And then we're going to now multiply 1.025 times 1,000. And because this question appears on session 2 of your MCAS exam, you are allowed to use a calculator. So I'm going to do 1,000 times 1.025, and I get the total amount of money to be 1,025. So that's the amount of money that is in the account after 1 year. For part C, Samantha's depositing $1,000 into a new savings account, where this time the interest is 3%, which is compounded semi-annually or twice a year. And she doesn't deposit money into or withdraw from it for 1.5 years. So write an equation that can be used to determine the amount of money in dollars in the new savings account. So when it says to write an equation, okay, we're going to take the equation they were given us, which is what I have rewritten here. It's the original $1,000 times 1 plus R divided by N times N times T power. Okay, so when they want us to write the equation, they want us to fill in the information. So remember, R is rate as a decimal. Okay, so we need to convert that 3% into a decimal. So again, we need to move the decimal 2 places, okay, to convert from percent to a decimal. So that means if I have 3, my decimal point is always at the end, I'm going to move it 2 decimal places. So as a decimal, my rate will be 0.03. Now, t in years, in this case where it said it's 1.5 years. So that's actually going to be 1.5. And then n represented how often the interest is compounded. Now that told us it was twice a year. So n, it will equal 2. So now we have to write the equation. We are going to need to fill in this information. So a will equal 1,000 times 1 plus. My rate is 0.03 divided by n, which is 2, to the n times t power. Now n is 2, and I'm going to multiply that times t, which is 1.5 years. And you'll notice that part D, it wants us to use this equation to solve for the amount of money in the account. So now we're going to take this new equation we just wrote and solve for the amount of money that will be in the account. So we had 1,000 times 1 plus 0.03 divided by 2 to the 2 times 1.5 power. Okay. So the key to solving any of these really strange equations is making sure you follow order of operations. So we always do parentheses first. So this is going to give me 1,000 times. Now inside my parentheses, I need to do the division before we add. So I'm going to do 0.3 divided by 2, and that gives me 0.15. I'm going to bring down my exponent, and then that gives me 1 plus 0.15, so that's going to be 1.15. And then I need to raise it to this power here. Now that we've simplified the parentheses, I need to do the exponents. Well, I have to multiply those exponents first before I can raise 1.15 to that power. So 2 times 1.5 is 3. Okay. So then that means I need to do 1.15 to the third power. Now, if you have a calculator, you can that allows you to just raise it to the third power. You can just raise it to the third power and hit enter. Or that would be the same as saying 1.15 times 1.15 times 1.15. So it's 1.15 times itself 3 times. Either way, you get the same answer, which is going to give me, in my parentheses, 1.52. 2 decimal places is, you want to use at least 2 decimal places, so that gives me 1.52 approximately. If you wanted to take it to an additional decimal place, it comes to 0.5208. Because the 8 is above 5, I could change that 0 to a 1 to be even more accurate. And then my final answer will be that number I just raised to the third power times 1,000. So I'm going to have 1.521 times 1,000, which will give me $1,521. And that is the answer to part D. And again, this is an open response, or what they're calling a constructed response. So, as a reminder, all of this work needs to be written or typed out. You have to show all of your work, all of it. So everything we just wrote down here needs to be, each step needs to be written out to receive full credit.